Dear students, let's continue from where we left in the last class. Let's have a look at the next question. Question 6. Limit extends to 0 sine of step of cos x divided by 1 plus step of cos x. So, limit extends to 0. I'll consider left hand limit as well as right hand. First, let's have a look at left hand limit. That is, limit extends to 0 minus f of x. Sine of step of cos x divided by 1 plus step of cos x. Okay. Say here, since does not exist is one of the options, you have to be very cautious. I am not saying directly that it does not exist as the answer. You should be very cautious. You have to cross check whether limit exists or not. Okay. First, let's have a look at the left hand limit. Left hand limit, x is approaching 0 from left side. When x approaches 0 from left side, what happens to step of cos x? For this, let's have a look at the graph of cos x in the neighborhood of 0. This is the origin O. So, this is the graph of cos x, right? Okay. I am interested at this point. At 0, it reaches its maximum, the maximum value is 1. But just before 0, what happens? I am interested to know what happens just before 0. Okay. Just before 0. See, at x equal to 0, cos x is equal to 1. Just before 0. Just before 0 means I am saying say something like minus 0.1 or minus 0.01, etc. X is coming closer and closer to 0 from left side. Then what is the value of cos x? Cos x is very close to 1 but less than 1. Right? At 0, cos x is equal to 1. Just before 0, cos x, as you can see, this graph is increasing. At 0, it reaches 1. Just before 0, cos x is very close to 1. The value of cos x is very close to 1 but less than 1. Right? So that means cos x may take the value 0.9, 0.98, 0.99, etc. but not exactly equal to 1. It will be equal to 1 when x is equal to 0. But when x is very close to 0 but less than 0, then cos x value will be very close to 1 but less than 1. Say somewhere in the region 0.9, 0.98, 0.999, etc. At all those points, what happens to step 1? Step of 0.99, what is its value? 0. So what do you get then? Sine 0 divided by 1 plus 0. I am saying step of cos x will become 0. Sine 0 is 0, 0 by 1 is equal to 0. So left hand limit is 0. Then let's have a look at right hand limit. Right hand limit is equal to limit extends to 0 plus f of x. F of x is sine of step of cos x divided by 1 plus step of cos x. Okay. See now, x is approaching 0 from right side. When x approaches 0 from right side, what is the value of cos x? At 0, cos x is equal to 1. But just after 0, I mean, when x is equal to say 0.1, at 0.1, what is the value of cos x? Cos x value is very close to 1 but less than 1. Right? At 0, cos x, the maximum value of cos x is 1, which is obtained when x is equal to 0. I am talking about at x equal to 0.1 or at x equal to 0.01 or at x equal to 0.001, etc. At all those points, cos x value is very close to 1 but less than 1. When I say very close to 1 but less than 1, cos x value may take 0.9, 0.95, 0.98, 0.99, etc. All those values, step of cos x, I mean, I am talking about step of 0.9 or 0.99, 0.9999, etc. What is the value of step of all those? It is equal to 0. So, right hand limit will be sine 0 divided by 1 plus 0. That means sine 0 is 0 by 1 is equal to 0. Left hand limit is 0, right hand limit is 0. So, limit exists and the answer is 0, which is the second option. Okay. Seventh question. Limit extends to 2 plus step of 2 minus x plus step of x minus 2 is equal to what? Where step x is the greatest integer function. Okay. See, here we are not asked to find the limit, we are just asked to find the right hand limit. They are not asked us to find left hand as well as right hand limit. Only thing we need to find out is the right hand limit. Limit extends to 2 plus step of 2 minus x plus step of x minus 2. Okay. So when I write x tends to 2 plus, this is 0, 1, 2. X tends to 2 plus means x is coming close to 2. X is coming close to 2 from right side. X is very close to 2 but greater than 2. So I can think of x as 2.1, 2.01, 2.001, etc. So you take one value, directly you take 2.1 because right hand limit we are finding. Put x equal to 2.1, see what happens. 2 minus 2.1, 2 minus 2.1 will give you 0.1. And what is the value of step of 0.1? Step of 0.1 is 0 plus. Here what happens? 2.1 minus 2. 2.1 minus 2. Sorry, I made a mistake here. 2 minus 2.1. 2 minus 2.1 is minus 0.1. Right? What is the value of step of minus 0.1? Step of minus 0.1 is minus 1. Step of minus 0.1 is minus 1. Right? You know the graph of step x. Okay. We have seen this graph on n number of occasions. See, I am talking about step of minus 0.1. Step of minus 0.1. Minus 0.1 here is here. At minus 0.1, step of minus 0.1 will be equal to minus 1. Right? Plus. Now here if I put x as 2.1, I am getting 2.1 minus 2. 2.1 minus 2 means 0.1. What is the value of step of 0.1? Step of 0.1 at 0, this is 0, 0.1 is here. At 0.1, step of 0.1 is 0, minus 1 plus 0. It's equal to minus 1. Is it clear? Now you might be thinking, sir, how do you know that? They have only given that x is approaching 2 plus. By writing x tends to 2 plus, it only indicates that x is very close to 2 but greater than 2. What is the guarantee? Why should I take 2.1 only? It could be 2.01 also, it could be 2.001 also, it could be 2.05 also. Yes, you are right. You can take any one of those. I will take this 2.05. Let us see what happens. Put x as 2.05. If I put x as 2.05, I am getting 2 minus 2.05. 2 minus 2.05 means I am getting minus 0.05 plus 2.05 minus 2, that is 0.05. What is the value of step of minus 0.05? That is minus 2. Step of 0.05 is 0. So minus 1 plus 0. In that case also you will get minus 1. So you take anything in this interval, in the right neighborhood of 2, you will see that the value of this limit, the right hand limit, will always be equal to minus 1, which is the second option. Then limit extends to 0, e power step of mod sine x divided by step of x plus 1, where step denotes the greatest integer function. 1 pi does not exist, pi by 2. Okay. So here I will look at left hand limit and right hand limit separately. First I would like to find out left hand limit. That's equal to limit extends to 0 minus e to the power step of modulus of sine x divided by step of x plus 1. Okay. So x tends to 0 minus. Now for this, you can take x is approaching 0 from left side, means x is very close to 0 but less than 0. X is very close to 0 but less than 0. So you can take some value, say put x is equal to minus 0.1. Okay, minus 0.1 if I substitute that, sine of minus 0.1 will give you minus sine 0.1. Right? Modulus of sine 0.1 is sine 0.1 itself. So e power, you will get e power sine 0.1 divided by, what happens in the denominator? Sine 0.1 is very close to 0. Sine 0 is 0, so sine 0.1 is slightly more than 0. So you can say e power 0.1 or 0.01 divided by step of x plus 1. X is, I am taking x as minus 0.1. Minus 0.1 plus 1. What do you get? Minus 0.1 plus 1. So 1 minus 0.1, which is 0.9. Step of 0.9. What do you get? Step of 0.9 is equal to 0. E power 0.1 is 0 point something, some finite value, not 0. 0.1 or 0.01 or something like that. Denominator is 0. 0.1 by 0. This is tending to infinity. Okay. See, if you have not understood, I will draw you the graph of mod sin x. To draw the graph of mod sin x, first I will explain. You look at the graph of sin x. This is the graph of sin x, right? To draw the graph of mod sin x, what you do is, first you draw the graph of sin x. After that, look at the portion of the curve which lies below x-axis. See, from here to here it lies below x-axis, from here to here it lies below x-axis, etc. From here minus pi to 0 and here pi to 2 pi, then 3 pi to 4 pi, etc. Right? Wherever the graph lies below x-axis, take its image with respect to x-axis. This is the graph of sin x, right? Now I want to draw the graph of mod sin x. So draw the image of this with respect to x-axis. Okay. So this is the image. Similarly for this, take its image with respect to x-axis. So in this way, the graph will appear like this. This is the graph of mod sin x. Now I am saying x is approaching 0 from left side. X is approaching 0 from left side. X is very close to 0, so sin x is also very close to 0. Okay, sin x is positive. Sin x is positive, mod sin x is positive now. Right? So very close to 0 and positive. Very close to 0 and positive means you can take this will be 0.1. Step of 0.1. What will be the value of step of 0.1? Step of 0.1 is 0. So e power 0 numerator. Denominator, x is approaching 0 from left side. X is very close to 0 but less than 0. So x is very close to 0 but less than 0 means x plus 1. See, x is very close to 0 means I can take x is very close to 0 but less than 0. I take x equal minus 0.1. Then what happens to x plus 1? X plus 1 add 1 to this will give you 0.9. What is the value of step of 0.9? Step of 0.9 is 0. So that will give you 1 by 0 which does not exist. Right? Or you can say it tends to plus infinity. Then you look at right hand limit. What happens to right hand limit? That's equal to limit x tends to 0 plus e to the power step of mod sin x divided by step of x plus 1. That's equal to, here look at sin x. X is approaching 0 from right side. X is approaching 0 from right side means sin x is very close to 0. Sin x is very close to 0 but positive. So therefore mod sin x, that is also very close to 0 but positive. Okay. So I mean this mod sin x may take 0.1 or 0.01 etc. At all those points step off that will be equal to 0. So you get e power 0 there. And here x is very close to 0 but greater than 0, right? X is very close to 0 but greater than 0 means I can take x is equal to 0.1. If x is 0.1, what happens to x plus 1? X plus 1 will be equal to 1.1. So 1.1. Step of 1.1 I am finding. Step of 1.1 is 1. E power 0 by 1 is equal to 1. 1 by 1 is 1. So left hand limit does not exist. Or I can say left hand limit is infinity and right hand limit is plus 1. They are not equal. Therefore, the answer is does not exist. This limit does not exist. Then, 10th question. Limit x tends to 2 plus step x whole cube by 3 minus step of x by 3 whole cube is. Okay. So here we are asked to find the right hand limit. Limit x tends to 2 plus step x whole cube by 3 minus step of x by 3 whole cube. Okay. So x is approaching 2 from right side. When x is approaching 2 from right side means x is very close to 2 but greater than 2. So step of that value, step x as x approaches 2 from right side means x takes the values 2.1, 2.05, 2.01, 2.001 etc. At all those points step x value will be equal to 2 because whenever x lies between 2 and 3 step x is equal to 2. So this will become 2, 2 cube is 8, 8 by 3 minus, what happens to this? Step of x by 3, x is coming close to 2 means x takes the value say 2.1, 2.1 by 3. 2.1 or 2.101 or 2.001 etc. What is the value of 2 by 3? 2 by 3 is 0.666, right? So 2.1 by 3 may be approximately equal to 0.67 or 0.68. See, I don't want what is its exact value. I want to know whether it is greater than 1 or less than 1. When x is approaching 2 from right side, when x is approaching 2 from right side, x value is very close to 2 in this interval. X value is very close to 2 but greater than 2. So x is very close to 2 but greater than 2 means clearly x is less than 3. Whenever x is less than 3, x by 3 is less than 1. If x by 3 is less than 1, step off x by 3. So 2.1 by 3 is 0.67. Step of 0.67 is 0. And 0 cube is 0. 8 by 3 minus 0. Answer is 8 by 3, which is the third option. Then 13th question. Limit x tends to 0. 1 minus cos x divided by x into log 1 plus x. 1 minus cos x divided by x into log 1 plus x. Okay, x tends to 0, that 2 from the previous one. Now in the denominator there is log 1 plus x. I will divide by x here. To compensate I will multiply by x. Or the x is there, it will become x square. Why did I do so? Because I know this formula. Limit x tends to 0, log 1 plus x divided by x is equal to 1. I know this formula, I want to use that formula, so I have multiplied and divided by x. Initially we had x into log 1 plus x. For log 1 plus x, I wanted that x in the denominator, so I have divided by x. Then to compensate it, I have multiplied by x. Just because I want to use this formula. I think you also know this formula. Okay, fine. Now as x approaches 0, log 1 plus x by x becomes 1. So we are left with limit x tends to 0, 1 minus cos x divided by x square. And this is equal to 1 by 2. We have seen it on so many occasions. Directly you can write. If not, use L-Hospital's rule. Because if I directly apply the limit, 1 minus 1, that is 0, cos 0 is 1. 1 minus 1 is 0. Denominator also 0. 0 by 0, use L-Hospital's rule. If I differentiate, I am getting sin x by 2x. Right? So then sin x by x as x approaches 0 becomes 1. So answer is 1 by 2. Fourth option. Then 16th question. Limit x tends to 0. Cos 4x plus a cos 2x plus b divided by x bar 4 is finite. Then the value of a and b are respectively. Limit x tends to 0. Cos 4x plus a cos 2x plus b divided by x power 4. Okay. See, they have given that this limit is finite. Then what are the values of a and b? That's the question. This limit is, this should be finite. Okay. Directly I will apply the limit. If I directly apply the limit, we are getting 1 plus a plus b. Right? Put x as 0, cos 0 is 1. So we get 1 plus a plus b in the numerator. And in the denominator, we are getting 0. Okay. So now what is 1 plus a plus b by 0? It depends on what is 1 plus a plus b. If this numerator is positive, if the numerator is positive, then this expression will reach plus infinity. some positive quantity by 0, if this is positive, numerator is positive, then that by 0, this will tend to plus infinity. But they have given that it should be finite. So that means this cannot be positive. Right? Then, if it is negative, if the numerator 1 plus a plus b is negative, if 1 plus a plus b is negative, then this expression will tend to minus infinity, will be equal to minus infinity. Negative quantity by 0 will take it to minus infinity. Okay. So if it is minus infinity, again that is also not finite. Infinity you are saying, whether it is plus infinity or minus infinity. So now see, if this numerator, if it is positive, then this limit is tending to plus infinity. If it is negative, then the limit is tending to minus infinity. So in both cases, when this 1 plus a plus b is positive or when this 1 plus a plus b is negative, we are getting the limiting value as infinity, either plus infinity or minus infinity. But what they have given? They have given that this limiting value is, this limit is a finite value. This limit is finite, they are saying. So if it is finite means, see, we have seen that it cannot be positive, because if it is positive, this limit is tending to plus infinity. It cannot be negative, because when this is negative, this limit is tending to minus infinity. Cannot be positive, cannot be negative means only one option left. What is that option? 0. Right? So 1 plus a plus b must be equal to 0, because if it is equal to 0, then it is of the form 0 by 0. If it is of the form 0 by 0, then it is an indeterminate form. Cannot say infinite form, it's an indeterminate form, 0 by 0. Then what we do? We will use L-Hospital's rule or any other method to evaluate that limit. Right? But if it is not 0 by 0 form, if you have some finite quantity, some positive by 0 or some negative by 0, then this will be either plus infinity or minus infinity. Okay? So given that this limit is finite, therefore this numerator must be equal to 0. So numerator is equal to 0, 1 plus a plus b is equal to 0 means a plus b is equal to minus 1. Now verify the options. In which option do we have a plus b as minus 1? First option, a plus b will give you 9, cannot be the answer. Second option, a plus b will give you minus 9, that's not the answer. Third option will give you a plus b is equal to minus 1, may be the answer. And fourth option, luckily, gives us 9, therefore that cannot be the answer. Hence the answer is minus 4 and 3. A is minus 4 and b is equal to 3. Okay? That's it. That's the answer. I mean, now you might ask, sir, here we are lucky that there is only one option which is giving you the sum a plus b as minus 1. But in the exam, what do we do if all the 4 options, like we had in an earlier problem, where if all the 4 options satisfy this condition, then what do we do? You leave that question and go to the next question. That is one of the options. Anyway, I'll explain it now. See, here, if we directly apply the limit, we are going to get 1 plus a plus b by 0. So it should be of the form 0 by 0. Then only we get finite volume. Okay. So if it is on the form 0 by 0, then we use L-Hospital's rule. Okay. So L-Hospital's rule, limit extends to 0. Minus derivative of cos 4x is minus sine 4x into 4 minus a into sine 2x into 2 derivative is 0 divided by 4x cubed. Okay, I'll take 2 as common and cancel it. So you have limit extends to 0 minus 2 sine 2x. I'll cancel 2 minus minus 2 sine 4x minus a sine 2x divided by 2x cubed. Now if I apply the limit, I am getting 0 minus 0, that is 0, 0 by 0 form. Okay, it is 0 by 0 form. Again I will use L-Hospital's rule. That's equal to limit extends to 0. What do you get? Differentiate it. Derivative sine 4x is cos 4x into 4. So minus 8 into cos 4x plus minus 2a cos 2x divided by 6x square. Derivative of x cubed is 3x square. Okay. Now if I apply the limit, I am getting minus 8 minus 2a divided by 6. Right? Sorry. If I directly apply the limit now, I am getting minus 8 minus 2a by 0. Denominator is 0. Numerator put x as 0, cos 0 is 1. So minus 8 here. There cos 0 is 1 minus 2a. Minus 8 minus 2a by 0. Now again use the same logic. If this numerator is positive, then this limiting value will be equal to plus infinity. If this is negative, then this value, this expression will tend to minus infinity. Okay, so but given that this limit is finite, therefore it cannot be positive, cannot be negative, it should be equal to 0. Minus 8 minus 2a is equal to 0, so 2a is equal to 8 minus 8, hence a is equal to minus 4. Already we have seen that a plus b is equal to minus 1, so when a is minus 4, b must be equal to 3. So in that way we can get the answer. Okay. Next question. 18th. The value of limit extends to 0, cos sin x minus cos x divided by x power 4 is limit extends to 0, cos sin x minus cos x divided by x power 4. Okay. Here if I directly apply the limit, I am getting cos of sin 0. Sin 0 is 0. Then cos 0 is 1. Minus cos 0, 1. 1 minus 1 is 0. Divided by denominator x power 4 is there. When I put x as 0, there also I am getting 0. So 0 by 0 is an indeterminate form. Whenever we get a 0 by 0, usually we go for L'Hospital's rule. However, in this particular problem, it is not advisable. Why? Because now denominator is x power 4. So once if you differentiate, you get 4x cube. There also you will get 0. Again, if you differentiate, you are going to get denominator of 4x cube is 12x square. There also 0. Again, you have to differentiate 24x. Again, you have to differentiate 24. Okay. So you may have to use L'Hospital rule 4 times. You may have to differentiate it 4 times. Differentiating this denominator 4 times is not an issue. Everybody will do it. But the problem comes with the numerator. Differentiating cos sin x 4 times is not an easy task. Because, maybe easy, but it is time consuming. Remember that in CET we will have approximately 1 minute per question, right? So you cannot differentiate it 4 times within 1 minute. You just observe what happens. Once if I differentiate, derivative of cos sin x is minus sin x into cos x. Okay, minus sin x into cos x plus sin x. After that, if you differentiate minus sin x into cos x, you are going to get a minus sin x into minus sin x plus cos x into minus cos sin x into cos x plus sin x. That is if you differentiate twice. Remember what happens, you have to differentiate 4 times. Okay. So it will take a lot of time. Therefore, what I will do here is I use the formula cos C minus cos D. Don't ask me what is that, sir. You know this formula or should know this formula. Cos C minus cos D. Cos C minus cos D. In trigonometry in first year we have studied that this is equal to minus 2 sin C plus D by 2 into sin C minus D by 2. Cos C minus cos D is equal to minus 2 sin C plus D by 2 into sin C minus D by 2. Okay. So this is a formula we know. Let us make use of this formula. Here in place of C we have sin x and in place of D we have x. So this is equal to limit extends to 0. Cos C minus cos D minus 2 sin C plus D by 2 minus 2 sin C plus D by 2, that is sin x plus x by 2, C plus D, sin x plus x by 2 into sin C minus D by 2. C minus D by 2 means sin x minus x by 2 divided by x power 4. Okay, so by using that formula cos A minus cos D, this is what we get. Okay, so now as x tends to 0, this sin x plus x by 2 and also sin x minus x by 2 tends to 0. So you can think of this as limit theta tends to 0 sin theta. When sin theta is there in the numerator, we prefer theta in the denominator because we want to use the formula limit theta tends to 0 sin theta by theta equal to 1. Okay, so for that I do it in this way. Limit x tends to 0 minus 2 sin x plus x by 2 divided by this x power 4 is there as it is sin x plus x by 2 into sin x plus x by 2 into sin of sin x minus x by 2 divided by sin x minus x by 2 into sin x minus x by 2. Okay, just observe what I have done here. See, we had a sin of sin x plus x by 2. I have divided by sin x plus x by 2. Then to compensate, I have multiplied. Similarly, here we had sin theta. This is theta. Then when you have sin theta in the numerator, we want another theta in the denominator. It's as good as sin theta by theta. So then to compensate it, I have multiplied by that sin x minus x by 2. Now as x tends to 0, this sin x, this is like a sin theta by theta. This expression will become 1. Similarly, this expression will also become 1. Okay? So then this is 1, this is 1. What is remaining now? Here minus 2 by x power 4 into sin x plus x by 2 into sin x minus x by 2. One of those two I can cancel. Sin x plus x into sin x minus x, it looks like a plus b into a minus b. A plus b into a minus b is equal to a square minus b square. So sin square x minus x square we get. Sin square x minus x square. Take this minus inside, it will become x square minus sin square x. I will continue here. So we will be left with limit x tends to 0, x square minus sin square x divided by x square minus sin square x. This x power 4 is there and one of those two will remain. So 2x power 4, this much will remain. Now if you apply the limit, what happens? Still you are getting 0 by 0 only. But this looks much easier or much simpler when compared to this. You go for a L'Hospital's rule now. So limit x tends to 0. If I differentiate, I am going to get 2x minus 2 sin x cos x divided by 2x power 4. Okay? That 2 sin x cos x, I will write it as sin 2x. Sorry, I am differentiating it. So derivative of x square is 2x. Derivative of sin square x is 2 sin x cos x. That 2 sin x cos x I am writing it as sin 2x. Derivative of this is 8x cubed. Okay. Now if I apply the limit as x tends to 0, here 2x, 2 into 0, this is 0. Sin 0 is 0. Numerator is 0 now. Denominator also 0. Use L Hospital's rule again. Limit x tends to 0. 2 minus, what is the derivative of sin 2x? Derivative of sin 2x is cos 2x into 2 divided by derivative of this is 24 into x square. Okay? So now I have a shortage of space here. I will rub this. I will continue here. I will take 2 as common. Then I will cancel that 2. Then you are left with 1 minus cos 2x. Okay? I have taken 2 as common. 2 minus cos 2x into 2. I have taken 2 as common. 2 into 1 minus cos 2x. Divided by 24x square is there. 2 I will cancel. Then we will have 12x square. Okay. Now 1 minus cos 2x. I can use the formula 1 minus cos theta. 1 minus cos theta is equal to 2 sin square theta by 2. So this will give you 2 sine square theta by 2, 2x by 2, that is x, divided by 12x square. Okay? See, I have not differentiated it. I am not using L Hospital's rule here. I am just using 1 minus cos theta formula. 1 minus cos theta is equal to 2 sine square theta by 2. So 2 sine square x divided by 12x square is there. As x tends to 0, sine square x by x square becomes 1. So then 2 by 12, which is equal to 1 by 6. Okay, 1 by 6, which is the second option. Okay, next question. 20th. Limit x tends to 0, sin x into sin pi by 3 plus x into sin pi by 3 minus x divided by x. X tends to 0, sin x into sin pi by 3 plus x into sin pi by 3 minus x. Okay. Now as x approaches 0, what happens to sin x by x? Sin x by x becomes 1. Okay, this expression is 1. Apply the limit for the others. What do you do? Put x as 0. I am getting sin pi by 3 into sin pi by 3. Sin pi by 3 is root 3 by 2 into root 3 by 2. Root 3 by 2 into root 3 by 2 will give us 3 by 4, which is the first option. Okay. Next question. 21st. Limit x tends to pi by 2. Cosecant x minus cot x divided by x is equal. Limit x tends to pi by 2. Cosecant x minus cot x divided by x. This is equal to. Okay. See now, if I directly apply the limit, what happens? Cosecant pi by 2. What is the value of cosecant pi by 2? 1 minus cot pi by 2. Cosecant pi by 2, if I directly apply, cosecant pi by 2 is 1 minus cot pi by 2. Cot pi by 2 is 0 divided by pi by 2. Okay. It's not extends to 0, it's extends to pi by 2. So 1 minus 0 is 1 by pi by 2. So answer is 2 by pi. 2 by pi, which is the second option. Okay, with this I'll end today's class. We'll continue in the next class. Thank you.